Welcome to Experimental, the science show that explains why dogs watch TV, women pee in the snow, and how going to bed in rubber just might make you slim. Later on, we'll be torturing teenagers with high-pitched sound and trying not to torture a Scotswoman by using helium to improve the sound of bagpipes. But first, let's head down under for a bit of canine vision. Australia, where veterinary scientist Paul McGreevy at the University of Sydney and his dog Wally have discovered something amazing. If you want to know what a dog sees, look at the length of his nose. Until now, many scientists believed that all dogs had the same eyes and saw the world the same way. But start measuring dogs' skulls and it soon becomes obvious that you can't cram a big dog's eyes into a little dog's head.
So what we did, we compared the eye volumes of different dogs. And for instance, here's an eye from a Maltese, which is a toy breed, and here's an eye from a Rottweiler. And you can see that there's a fairly appreciable difference in volume between the Rottweiler and the Maltese.
Having shown that dogs' eyes differed in size, McGreevy started looking for other differences inside the eyes. What he found could help to explain why different breeds behave in different ways. In the back of the eye are light-sensitive layers of vision cells called the retina. In humans, these cells are concentrated in a single spot known as the fovea. So we see lots of detail in the centre of our vision. It was assumed that all dogs have what's known as a visual streak, a line of vision cells running across the eye. This streak gives dogs a much wider field of view than humans and allows them to detect movement better. But McGreevy discovered that all dogs were not the same.
What really surprised us was that some dogs didn't even have a visual streak. Instead, they had a concentration of cells in the centre of their eyes called an area centralis.
So some dogs had an area centralis similar to a human fovea. But when McGreevy compared the data from his microscope work with his measurement of skull size, he noticed something even more amazing.
When we cross-checked the information about the visual streaks with the information about the skull shapes, we were really surprised because all of the dogs that had no visual streak had really short noses. In contrast, the dogs with long noses had beautiful, long visual streaks.
If McGreevy is right, then you can work out what a dog sees just by looking at the length of his nose. Experimental decided to put this theory to the test. Wally is joined by two friends. Cinnamon, a pug, has a very short nose. Sebastian is a Saluki and has an extremely long nose. Wally's snout lies somewhere in the middle. Test 1. How will each dog fare in our trial of peripheral vision? While the owners encourage their dogs to look straight ahead, our assistant will sneak up behind them and drop a marker when she's noticed.
Huh?
Cinnamon the pug didn't see our assistant until she was almost beside him. No chance of sneaking up on a Saluki, though. And Wally spotted her early as well. So short-nosed dogs, bad peripheral vision. Long-nosed dogs, good peripheral vision. Test 2. We borrowed a dog track to see which of our four-legged friends will respond to a fast-moving object. No surprise there. Salukis were bred by the ancient Egyptians to hunt gazelle. Wally is no slouch either, but I don't think he's going to catch that hare. And now for Cinnamon. Oh dear. He hasn't even seen the rabbit. It's all a bit of a blur. Better go for a lie down. So, 2 out of 3 tests done, and Cinnamon the pug is not having a lot of luck. There must be something pugs are good at. At last, Cinnamon is triumphant. Sebastian doesn't show any interest in the TV at all. And as for Wally, well, it probably wasn't his favourite channel. But short-nosed pugs have a narrow field of view, see lots of detail, and aren't distracted by things going on around them. Perfect for watching television. Wally and Sebastian, meanwhile, would much rather go and play in the park.
This sort of information can help us understand a bit about the dog's behaviour. Short-nosed dogs are concentrating on things right in front of them. Long-nosed dogs are scanning the horizon, the periphery, and they don't tend to stare at their owners the same way that short-nosed dogs do.
So human vision allows McGreevy to see the entire span of Sydney Harbour Bridge. And if you've got a longer-nosed dog like Wally, he'll see a lot more. Before we offer the fatties amongst you the ultimate calorie-uncontrolled diet, let's get all Highland at the test department. What a cliché. Scottish melodies and images of the Highlands. Let's see if the test department can spice things up with the application of some science. That's right. We've crossed Old Lang Syne with a balloon full of helium. But why does Mary's voice sound like Donald Duck kicked in the groin? It's all to do with the speed of sound. In air, sound travels at around 350 metres per second. But in helium, it's around 1,000 metres per second. This totally changes the resonances in the throat, effectively raising the pitch. But what would helium do to bagpipes? Let's see. Not a great improvement there, then.
And it's not just the noise that's bad. Breathing helium can kill you. So don't do it at home.
Still to come on Experimental, how to empty a room full of Welsh kids and light a fire with hot air. But first, a question much asked by Inuit and mountaineers. Why is it that cold weather makes you want to pee? Let's leave the sauna and find out. As you get cold, the blood flows from the surface and into the centre of your body. As a result, the kidneys receive more blood and become more active. But that's not all. Cold weather reduces the amount of sweating. And that could mean even more liquid needing to find a way out each hour. And ultimately, it will find a way out. Welcome to one of the biggest problems of the 21st century. No, not food, obesity. The result of too much of the stuff. It's so bad that now 65% of Americans are overweight. But if scientists at Washington University in St. Louis are right, there could soon be a revolutionary new way of getting rid of all that flab by living in a germ-free environment. Of course, life in a bubble may cause a few other problems with the social life, and you won't exactly be showing off that wonderful new figure. But there may be one really big advantage to this new diet. You see, the boffins of Washington University believe that living in germ-free bubbles like these mice might allow you to eat more while still losing weight. And that's what Dr. Jeffrey Gordon and his colleagues are trying to prove.
We wanted to determine whether the bacteria that live in our guts that influences our predisposition to leanness or obesity.
Germs are a nasty name for bacteria, most of which are quite friendly.
Hi,
So friendly that the average human will have around 100 trillion individual bacteria living quite happily in their gut, the whole lot weighing in at around 1.5 kilos. Dr. Gordon's theory was that the germs in the guts of mice help extract calories from the food they eat and transfer it into fat. And to prove it, he needed to work with a strain of germ-free mice with no bacteria in their gut at all. For the squeamish, now is the time to make that cup of tea. When in the womb, embryos are totally germ-free. To keep them that way, scientists had to perform caesarean sections on their mothers, delivering them into sterile bubbles and then feeding them by hand with germ-free milk. Eventually, they had a colony of totally germ-free mice. But did his slimming theory work?
What we found was pretty amazing. The germ-free mice ate more food, but were leaner than their conventionally raised counterparts.
They proved this by feeding two groups of mice with the same food. As well as his sterile mice in their germ-free environment, Dr. Gordon raised a second group, with their guts full of germs in similar sealed balloons. Both lived the life of couch potatoes, doing little more than eat and eat and eat. After a few weeks, the germ-free mice were still slim and trim, but those with a gut full of bacteria were distinctly plump. As a final check on those results, Dr. Gordon's team took some of those germ-free mice out into the big bad world and infected them with some of the bacteria found in the guts of their fat friends.
We found that if you add a microbial community to those germ-free mice, they rapidly and very dramatically gain fat, even though they're eating less.
Although it's mice, not men, we're talking about, our guts and the bacteria in them are roughly the same. So, if the bacteria in our guts is helping to make us fat, then switching to a germ-free life while still eating a high-calorie diet might just be the next big thing. Or perhaps not. Living in a bubble might take too much of the fun out of life to be worth it. Still to come on Experimental, a solution to this man's drink problem. How this little tube led to the diesel engine, and we'll get the chance to zap some Welsh kids with high-pitched sound.
Oh my God!
But first... At the test department, Horace is trying to look cool by the pool, but there's something on his mind. The length of his snorkel. Would he be even cooler if he could make it longer? The principle behind the snorkel is devilishly simple. It's a tube that allows you to breathe with your face underwater. Dive any deeper and you'll normally use scuba gear. But why couldn't you use a longer tube? Impressive snorkel. Now let's try it. Oh dear, not so cool. It all seems to have gone wrong. But why? Well, it's all to do with the weight of water. Go down more than about 1.5 meters, and the weight of water pushing on your body is so great that your lungs cannot expand against it, making breathing impossible. Which is why a normal snorkel is only about 30 centimeters long. Dive any deeper, and you need scuba gear, which automatically regulates the pressure of air coming out of the tank, allowing you to breathe safely. So, Horace, science has proved that it's better to have a short one that works than a long one that no one can suck on.
Don't try this at home.
Yet to come on Experimental, how the demise of the audio cassette saved this man's beer. And a chance to go camping with the test department. But first, let's annoy some kids.
Can you all hear that? Yeah. Because I can. Yeah. Right. All hear that? I can hear that as well. Yeah?
Be honest.
Experimental has travelled to South Wales to meet a man with a fantastic method of getting up kids' noses.
That's horrible.
Jackpot.
That's really annoying.
Worse still, Howard Stapleton, acoustics whiz kid, seems to enjoy it. But before we condemn him, he is doing it for a reason.
Oh my god!
Outside Howard's immaculate front room, it's a war zone. Gangs of hooded teenagers have taken over the street, and no one over 21 feels safe to venture out. That's a load of old rubbish, actually. This is Newport, South Wales, where the teenagers simply hang around outside supermarkets and smoke the occasional cigarette. But that was enough to put Howard off getting his bread and milk.
Last summer holidays, my local shop was having particular problems with a gang of teenagers hanging around outside the shop, especially late into the evening. One night I went out there to buy my milk and not even I would walk through them. I approached the shopkeeper the following day and said, "I've got an idea, can I try it out?" And he said yes.
The big idea was this. A speaker emits an annoying buzz that only teenagers can hear. It exploits the fact that as you grow older, your ability to hear really high sounds deteriorates. So whilst a teenager might be deafened by really high sounds, an older person won't be able to hear a thing.
Let's have a look.
Don't believe us? Well, let's check out Howard's little box of tricks.
That's 12 kilohertz, I can still hear that clearly. 15, I'm aware of it. As I run up to 16, and then we're up to around about the 17 thereabouts, which the mosquito system uses. And that is a frequency that someone with young hearing does hear very clearly.
The idea is simple, but it took Howard a year to come up with a system that really annoyed the young ears of Newport. But once his prototype was fixed to the wall of his local shop, the results were dramatic.
Well, the first few days, kids were asking about the noise and saying, could we turn it off? And then they just sort of disappeared. And I thought it was a coincidence. They must have gone, there was another reason for it, but they haven't come back.
Experimental was keen to talk to a teenager about the effects of Howard's little box. But we couldn't find one. So we had to talk to some people who'd never heard it working.
To be fair, since the machine is out, I've noticed, a vast difference.
There used to be, especially around that area there, gangs of kids at night, drinking and all sorts. But it's definitely sorted that out.
Right, here we go. It's nice high frequency, and what I want you to do is each one of you can hear the noise. Will you put your hand up in the air?
Howard now wants to make a portable device to help police clear the streets of young people.
Oh my god.
Oh, you don't like that, do you? No, that's cool.
However, he's having problems with his research guinea pigs.
Hello.
In a moment, we'll be off to Holland to create the perfect beer with a defunct cassette system. But first, let's rough it a bit with that nice girl from the test department. Welcome to the Test Department School of Unlikely Survival Skills, in which we test one of the oldest fire-making methods known to man, or in this case, woman. No, not rubbing sticks, but the Malaysian fire piston. As used by Malaysians and other Southeast Asian peoples before they bought matches. How does it work? Take one piece of tinder and place it at the bottom of the tube. Stick the piston on and give it a good hard whack, and lo and behold, the tinder ignites. What's happening is, as the air in the cylinder is compressed by the piston, it heats up, ultimately getting so hot that the tinder is ignited. Is this just an odd but useless piece of science? Well, no. It's exactly the same principle as used in a diesel engine, where diesel is squirted into a cylinder full of air which is compressed by the piston until it ignites. Mind you, for lighting fires, the fire piston does take a lot of practice, so you'd be better off with matches, so long as it's not too windy. Finally on experimental, a nice cool drink. Experimental has headed to Lieshout in the Netherlands. Like many Dutch towns, it's got a canal, pretty houses, and some bars where men meet to discuss their problems over beers that are rattled off the production line of the local brewery only hours before. The same family has been brewing beer here for over 300 years, and now it's Wietse van den Boogaard who's stirring the hops in the copper vats.
It's my passion to brew beer. I like the brewing, I like the drinking, I like the product, I like the bars where the beer is. So, yeah, that's the passion, huh?
But there is one thing about his lovely brew he hates, and that's the fact that when he pours his nectar fresh from the tap, it's all cloudy and tastes yeasty. Traditionally, brewers have turned to a powder made of Cretaceous algae to filter the nasties out. It's called kieselguhr, and Wietse doesn't like it.
But in kieselguhr you have some problems of safety requirements because it's very dusty. And it's a waste material, it's only for one-way use.
Brew 1 week's worth of beer, and you'll have to get rid of 9,000 kilos of kieselguhr sludge, which environmentalists hate. But no more. You see, just last year, Wietse met another man with a problem down at his local bar. Peter Seagal was a research scientist for electronics giant Philips, who dropped in to drown his own problems.
I've been an engineer with Philips now for many years, and the last job I had is to lead the technical side of a big project that was really started by Philips to create a digital audio recording system called DCC.
DCC should have been a surefire winner for Philips. In 1963, they brought out the audio cassette, which soon became almost as essential in a car as its engine. The digital compact cassette was simply a digital version of their old money spinner. It could play and record CD-quality digital tapes, as well as the old audio cassettes. Sadly, no one wanted tape anymore, digital or analogue. They wanted discs. So the whole £1 million tape project was canned in 1996, just 4 years after its launch.
Unfortunately, it was a technical success, great technical success, but even bigger commercial flop.
The key to DCC was recording heads with tiny holes blasted through them. To make them, silicone wafers are coated with thin layers of silver nitrate and a photosensitive lacquer, then fed into a wafer stepper, a specialised machine that projects a pattern of dots on the material and then uses a laser to cut out over 5 billion holes, exactly 1 micron deep. Brilliant. But after the demise of DCC, absolutely useless.
So many people, so enthusiastically, put in so much effort to develop this technology. And I felt it would have been such a shame if that was not going to be used. And I was absolutely convinced there must be an area where we can make a breakthrough product with this breakthrough technology. And we found one.
That's right. While sipping his troubles away in the bar with Wietse, Peter realised that he had the solution to the beer brewer's problems. That defunct DCC technology was just what Wietse needed to get rid of the clouds in his beer. All he had to do was bin the kieselguhr and replace it with silicone filters from Peter's old cassette player. And bingo, his nectar flowed amber.
The beauty of this product that it's so simple. It's a kind of digital filter. If you pour fluid over it, particles that are smaller simply go through it, and particles that are just a little bit bigger do not go through it.
And that's the beauty of the filter. Those yeast particles that cloud up the beer are just too big to squeeze through the holes. The result is the amber nectar that Wietse has always dreamed of. But did it taste any better? Well, we thought we'd ask an independent expert, Carl, our sound recordist. Unfortunately, he proved incapable of doing 2 things at once and left his microphone switched off. So you'll have to guess his opinion from his facial expressions. But we think it's a thumbs up. Welcome to Experimental, the science show that hugs you down the phone and drives your dog wild with excitement. Later on, we'll be using science to blast away at the secrets of this magician, inflicting 3-year-old sandwiches on the good people of Natick, Massachusetts, and examining the physical properties of a raspberry at 500 frames a second. But first, let's snuggle up closer together. Rome, Rome, wonderful Rome. The Colosseum, the Trevi Fountain, daredevil drivers, feral cats. And of course, it's one of the world's most romantic cities. A fitting backdrop for a piece of fashion that aims to keep you in touch with your main squeeze. Literally.
Ooh.
I'm gonna fly.
It's funny.
It's an inflatable shirt that allows you to send and receive hugs via text messages on your mobile phone.
Squeeze. Like someone's properly holding me in their arms.
And its inventors, Francesca Rosella and Ryan Gentz, believe that in the future we'll all be wearing clothing like this.
I've always had a passion for like fashion, and I've been also a fashion designer for a long time. But I also had a passion for technology, and I tried to combine both.
The shirt was designed to demonstrate how mobile phone technology could be integrated into clothing. But it's been so popular that Francesca and Ryan are now ready to market it.
We get requests almost on a daily basis from people that want to sell the shirt and people that want to buy the shirt for a huge amount of reasons, like reasons that we couldn't even have come up with in our research.
The Hug shirt contains a series of carefully positioned touch-sensitive pads. To send a hug, you open a special function on your phone and you give yourself a great big hug. An onboard computer records the strength and position of your hands and turns the data into a simple text message. At the receiving end, the text arrives. And if you like the sound of the sender, you choose to receive it. A tiny air pump fills the air pads to give the correct squeeze strength. And if that's not enough, the shirt even warms up to mimic the body heat of the sender. Ah, lovely. The company behind the invention is the techno fashion house Cute Circuit, run by real-life hugging partners Francesca and Ryan.
All the technology to develop this sort of thing is available today, and we already have working prototypes.
But how do you turn a circuit board into a hug? Ryan and Francesca started with t-shirts and pens, taking over 50 volunteers and drawing circles around their hands. Amazingly, they found out that we all hug the same. The final stage was to work out what a really good hug feels like and mold the technology to replicate it.
The result is like this package of technology. There is a sensor that is a very tiny flat sensor, like this one, that feels how strong you're hugging. And then inside there is a little pump here. And when I receive a hug, this pump starts to inflate a little balloon.
Ah, isn't that sweet? The cutting edge of 21st century hugging technology. But before all you cynics turn off, why not ponder on this fact? Hugging may actually help you live a longer, happier and healthier life. Studies have shown that hugging causes the brain to release hormones that make you feel relaxed and happy. Hugging also leads to a reduction in the release of stress hormones, chemicals that are linked to heart attacks. And this could explain why single people are more likely to get heart attacks than people in loving relationships. So it's a potent thing, this hugging, but would it convince you to buy Francesca's techno shirt?
Yes, definitely.
Yeah, that would be great. If this invention was available, I would probably like to send some hugs to my son when I'm not with him.
One for her, one for my son, then I can just keep text messaging hugs every night. This is amazing.
All the fashion people say, oh, we're never going to put technology into our clothes. And all the telecommunication people say, it has just to work, it doesn't have to look good. And instead, we're like merging these two things together, make them look really, really good, and give them an emotional value that really makes people think that is great to use.
Before the amazing Alim Amlani does strange things with a $5 note and an orange, let's head to the test department for some of the hottest science on television. Despite its popularity, there are some people who just cannot cope with a good curry. But there must be a better way to cool your mouth. To find out, we're going to test the effects of 3 curry house coolers: water, beer, and that yoghurt drink most tea-drinking Brits can't handle. But first, we have to set a benchmark. Our demonstrators here will each chew on a chili and score the pain out of 10. That's quite hot then. The sensation of spiciness is caused by the chemical compound capsaicin. But it doesn't actually burn the mouth at all. What it does is to bind to nerve receptors in the mouth that normally sense temperature. These nerves are stimulated and tell the brain that the mouth is being burnt. So even though we feel the pain, it's not actually burning you in the conventional sense. With this in mind, let's test the effectiveness of our 3 cooling drinks. So yogurt is the clear winner. And the reason? Fat. Capsaicin is soluble in fat, not water. And the milk in yogurt contains loads of fat, which dissolves the capsaicin and carries it safely away from your sensitive nerves. Perfect. So there it is. Stay away from the lager and go for a milky drink next time you go for a curry. Coming your way on Experimental, the scientist who believes every dog needs a mobile phone, and how the US Army get away with feeding their soldiers 3-year-old sandwiches. Experimental has travelled all the way to Vancouver to visit the University of British Columbia's Visual Cognition Labs, where they use a lot of fancy kit to examine something that might appear fairly trivial. And that is why magicians like research assistant Alim Amlani can pull off stunts like this. Just watch.
What I have over here is a piece of rope. Could you examine that? Sure. And could I borrow your ring for a moment? Sure. Perfect. A lot of the time, people aren't aware of everything happening in front of them, and what magicians are able to do is exploit that. The ring right over here goes onto the piece of rope, just like that. So things that are right in front of you sometimes go unseen. Now, it really is on the rope. You can tug on that if you want. What magicians have been doing is they're able to basically direct attention around a scene. So even though you're going to be looking at one thing, something could be happening right in front of your face and you wouldn't even see it. Now, what I'm going to do is I'm going to give you this end over here, don't let go. You take this end over here and don't let go. I can slide the ring this way, I can slide the ring this way, but what I cannot do is pull it off just like that. I cannot make it disappear just like that and land back on the finger just like that.
Alim knows exactly how his trick works. He just won't show us. Back at the Visual Cognition Lab, Dr. Ronald Rensick has a word for why people do not see what's in front of them. He calls it change blindness.
Change blindness is really the effect where people don't see large changes that are in front of them. These are changes that are very easily seen once you see them, but it takes a long, long time before people see them. Until they do, they're effectively blind, hence change blindness.
To prove how it works, Dr. Rensink and his fellow researchers have devised a number of tests to see exactly where we look. Tiny cameras track the movement of the pupil and plot the centre of their gaze on the image being viewed. The results were fascinating to researcher Elena Birmingham.
We found that overall, people look mostly at the eyes. So even though there are many objects to look at in the scene, they look primarily at the eye regions, which is a novel finding.
Just to prove how blind we are, watch this classic experiment. A student is asked to undertake a simple task, completing a questionnaire. As she works, the researcher, who she met for the first time a few moments ago, changes place with another. But will the student notice?
I think I'm done with this one.
Great. Thanks. Did you notice anything unusual about the experiment?
No.
Did you notice that me and another experimenter switched places halfway through?
Oh, no, I didn't notice that at all.
Now you may think that's impossible. But to prove how blind you really are, let's look at the ring trick again. Remember when the magician revealed the ring was on his finger?
I cannot make it disappear just like that and land back on the finger just like that.
That wasn't magic. If you'd only been watching, you'd have seen it was there all along.
I cannot make it disappear just like that and land back on the finger.
So why does this happen? Well, some scientists think it's all to do with your posterior parietal cortex, a little bit of the brain that's near the back. It's the bit that deals with short-term visual memory. Unfortunately, it's not big enough to process all the information sent to it, so it does something rather clever. It remembers just enough of the important things in an image to be able to recognize it again. So just like this, you blink, you open your eyes again, and so long as everything looks pretty much as it did a few milliseconds before, the brain will assume that nothing has changed. Even if it has. Did you notice the shadow beneath the Jeep coming and going? Probably not.
Inherently, we're susceptible to this. There's not that much we can do. All we can do is try to design our technology to minimize the possibility of this happening.
Just to show how susceptible we are to change blindness, watch this next trick very closely.
Could I borrow a $5 bill? Maybe could you just sign your name across the bill? Okay. Have you ever seen the trick, Eric, where the magician takes the bill, folds it up nice and small, and when he unfolds the bill, it is a $100 bill?
No, but I'd like to see it.
Too bad. Can you still feel your bill, by the way? All right, what we're going to try to do is something amazing. Watch. 1, 2, 3.
Okay. Where'd it go?
What I have over here is a knife. Now you can see the orange sealed on all sides. Inside this orange, right over here.
What? Eric, that's not my bill.
Take that out, take a look. Can you show that to the camera? Is that your name?
Yeah.
Thank you guys very, very much.
Did you see how he did it? No? Well, don't feel bad. Nor did we. But did you see the big gorilla halfway through? Well, just in case you didn't, here it is again.
Now you can see the orange sealed on all sides. Inside this orange.
Don't try this at home.
Still to come on Experimental, mobile phones for dogs, gourmet sandwiches for grunts, and the phantom raspberry blower. But first, welcome to the Great Test Department Grip Experiment, in which our 3 intrepid testers are going to find out which type of shoe has the best grip. Will it be number 1, the cheap plastic flip-flops from a seaside novelty store? Or number 2, professional leather-soled ballet shoes? Or finally number 3, a pair of expensive mountaineering boots that are guaranteed to get you up Everest the hard way? Whilst the gamblers amongst you are laying out your bets, let us ready the Test Department slipometer. Or rather, an electric drill, some rope, and some planks of wood. The idea is we can gradually increase the slope until our Test Department tester slips downwards. First up, those sturdy mountaineering boots. "5 degrees, 10, 20, 25, oh, and a slip at 35 degrees. But as expected, they're pretty good. Next, those natty little ballet shoes. All set, go. 5, 10, 15, 20. This is not bad, but hang on. Oh, they've gone at just 27.5 degrees. Well, well. And finally, those cheapo flip-flops. Here we go, straight through 5 and 10 degrees, 15, 20, 25, 30. This is amazing. They've reached a staggering 40 degrees. What a turn up for the books. So next time you're scaling the Eiger face, why not bin the boots and try a pair of £1.99 flip-flops instead? Did I hear the word frostbite? Coming up on Experimental, techie stuff for dogs and violence in the test department. But before all that, let's go snacking with the army.
Hello.
Here we are in Natick, Massachusetts, trying out a new kind of sandwich.
Yeah, it's good.
Not bad.
I like it.
It's a good thing they like it because this isn't an ordinary sandwich. These are high-tech sandwiches from a special batch made by the US military. Behold, the Forever Sandwich. The idea behind the sandwich is to make sure the infantry don't waste valuable fighting time messing around with mess tins. Instead, they eat on the run. Why? Well, it's hard to tell exactly when the boys in green are going to need to get out their guns and fight, so a ready supply of munchies must always be on hand. That's part of Michelle Richardson's job. She's from the Department of Defence Combat Feeding Directorate, and she was on the team which came up with this cunning plan.
This is a shelf-stable pocket sandwich. It's called shelf-stable because it has a 3-year shelf life. This is something that the soldier can't eat out of hand, doesn't require any preparation, and he can eat while on the move if needed.
But the bread is remarkable. Ultra-pasteurized, radioactive, sealed against the elements. How do you do that?
A lot of the stuff that goes in the bread is pretty common, such as mono and diglycerides to stop it getting stale, and ascorbic acid to stop the mould. So much for the bread. But what about the middle of the sandwich? Well, that too has a healthy squirt of glycerol to stop the bacteria growing, plus a few other unpronounceables which do much the same thing. But the key is not the chemicals in the sandwich, but the packaging. Not only is it more airtight than a tin can, but it contains a little package of oxygen-scavenging chemicals. Each of the sachets is filled with a chemical such as iron oxide, a molecule with a need for more oxygen atoms to keep it happy. Its effect is like a vacuum cleaner, sucking up any stray oxygen atoms it can get hold of. It's so effective that oxygen levels can be reduced to about 100 parts per million. The result is that all the moulds and other bacteria that need oxygen to live effectively suffocate. So just how long can one of these things last?
Food items should be able to last for 3 years at 80 degrees.
Yes, these babies can last 3 years in the field. Rain, sleet, sludge, and enemy fire. And just to prove it, these are from the Department of Defence's original batch, baked in April 2003.
Wow. Okay. Oh, goodness gracious.
Packed in here for 3 years. Why is it 3 years old?
And you're still eating. You didn't stop.
Isn't it amazing what science can do to us?
Whilst humans seem quite happy with this historic meal, other species seem a bit more choosy. Still to come on Experimental, the gizmo that got Fido here a little overexcited. But first, to the test department. What is it about blowing a raspberry that makes the raspberry sound? The test department decided to find out. We ran a series of medical tests on this prodigious raspberry blower. In a marathon session, our subject blew over 300 raspberries in just 1 hour, allowing the test department to draw a startling scientific conclusion. But what was it? It was that raspberry blowing is extremely annoying. A discovery which blew our demonstrator's mind but was hardly science. So, we got out our special 500 frame a second camera to have a closer look at what's going on. Revealed for the first time on your TV, the startling fact that it is the bottom lip that plays the dominant role in raspberry vibration. And for all that our raspberry blower has advanced the knowledge of humankind, we couldn't resist taking our revenge on the rude little squirt. Welcome to Scottsdale, Arizona. It's a pretty typical town, full of some of the good things about America. Like mobile phones, and some of the odd things about America, such as this woman and her dog.
And those guys. Yeah, she's pampered. Do we love her? We adore her. This is my passion.
So why is experimental here? Well, it's to meet this man, Cameron Robb, who's decided that the next big thing for a dog should be a phone.
I came up with the idea for a pet cell several years ago. I was on a business trip and I was talking to my daughter on the phone, and she was telling me a story about her friend losing her dog.
Yep, every cloud has a silver lining. Buddy may have run off and broken a few hearts along the way, but it got Cameron thinking. Pretty soon, he'd come up with, well, a Fido phone.
I just thought with technology advancements, wireless telephones and tracking devices, it would be a great product to come up with for finding a dog.
Just like the modern human phone with its WAPs, Bluetooth and MP3 abilities, actually talking is fairly low on the Fido phone's list. Key to this gizmo is the fact that it can be tracked from space. So as Buddy heads for a raid on the local canine sweetie shop, a big red blotch appears on his owner's computer screen, prompting some swift action. Even better, his position can be uploaded live onto your own tracking device. So when Buddy heads to the hills with his loot, the posse can be close behind. The device does also work as a phone, so your favourite animal can hear all the exciting things you've got in store for him when you get home.
Hey Sam, it's Mom.
I'm almost done working now, so as soon as I get home, I'll take it for a run and we'll head over to the park.
So, thanks
for being a good boy, and I'll talk to you soon.
But unfortunately, all that talk of parks can get some dogs overexcited.
I love you.
Bye-bye.
Welcome to Experimental, the science show where men dance with robots and eat on the toilet. Later on, we'll be switching off this man's brain, finding out why this man wants to replace pilots with rat brain cells, and we'll attempt to break a world record by making ice cream in under 18.78 seconds. But first, let's dance. Ah, what grace, what style, what beauty. It can only be ballroom dancing, Experimental's all-time favourite way of moving about to classical music. But like so many things in life, it's not much fun on your own. And when all the ladies are taken, even the great Fred Astaire would be left twiddling his thumbs. Well, thank God we're in Japan, because help is close at hand for those left behind by the pretty girls. Here amidst the beautiful Japanese mountains, robotics experts have rustled up a girl who just can't say no. She's a full-sized waltzing robot with the catchy name of PBDR, or Partner Ballroom Dance Robot. Part Marilyn Monroe, part Mickey Mouse, and just a hint of the Terminator. She's the brainchild of this man, Professor Kazuhiro Kasuge, from the University of Tohoku.
This robot is called Pinky, and this is Blue. They're partner ballroom dance robots. They were designed to waltz with male dance partners. The robot moves with 3 specially designed wheels that allow them to move anywhere on a flat surface. Also, around the waist, there's a force sensor that measures the force applied to the upper arm. Using this sensor, the robot can predict the sort of movements the partner would like to do, allowing them to move with the partner.
Like all dancers, Pinky needs to get in the mood to perform at her best. So we decided to set the ambience with a little light, a little smoke, and of course, a handsome partner. This is Takeda, a research assistant at the university. He had to take dancing lessons to help with the development of the robot, and he's the only man that Pinky moves her gears for. Waltzing involves improvisation around a number of set moves. For the robot to follow Takeda's lead, she has to be able to read subtle cues in his body language. In total, she knows 5 different moves and needs to be able to anticipate and react to each one successfully to waltz convincingly. It's all very clever stuff. But Kasuge has more than just ballroom dancing on his mind. Pinky is a showcase for technology that could help the elderly or less mobile. The same hardware that puts her into a world-time spin goes into this, an intelligent walking frame that puts on the brakes when you want to stand up, and can even sense when you're about to take a tumble.
Robots are the only devices that can interact with our environment. So robots are the final, ultimate systems that can physically assist your life. And it's for that reason we are doing our research.
Unfortunately, Pinky is strictly research, so our lonely hearts can only dream of taking her for a spin. But if she were available, would you be tempted?
Humans and robots are fundamentally different, so it might be good for an experience, but I'd have to think twice if I had to dance with a robot forever.
And who could blame him, especially when there are so many pretty girls left to fight for. In a moment, we're off to the laboratories at the University of London to look behind this chap's eyes. But first, let's go and have lunch with Horace in the test department. When Horace is not in the test department labs or accosting women in the name of science, you'll often find him at his desk, writing articles for learned journals. It's a desk like any other, but pride of place is given to Horace's photo of Dr. Charles Gerber. You see, it was Dr. Gerber's seminal work in 2002 on germ counts in the American office that changed Horace's life, leading him to totally re-evaluate his attitude to hygiene. You see, Dr. Gerber showed us that the filthiest place in the average office was the telephone handset, clocking up a score of around 25,000 bacteria per square inch, which explains why Horace is being so careful.
Hello. Hello.
Next up is the desk, with around 21,000 bacteria per square inch, a lot worse than the keyboard and the mouse, which have a population of between 3,300 and 1,700 bacteria per square inch. All of this makes the office a pretty dirty place, which is why when it comes to lunch, Horace likes to have it in the cleanest place in the office. That's right, the toilet seat, which on average has only 49 bacteria per square inch, 400 times cleaner than the desktop. Still to come from the test department, our answer to that vexing question. Will I get wetter if I run or walk in the rain? And our world record attempt. Can we make edible ice cream in less than 20 seconds?
Hello.
We spend 9 days a year doing it. We do it at home, in the office, and even out in public. It's usually over very quickly. And no, it's not sex. It's blinking. Not the subject of cutting-edge scientific research, you might think. Well, you'd be wrong. Believe it or not, no one knows why we blink, but don't notice it. Well, no one knew until this woman came along. Davina Bristow from the Department of Neurology at University College London. She's finally managed to shed light on the mystery.
What we found was that each time you blink, the visual parts of your brain are actually suppressed.
Blinking is like switching on the eye's windscreen wipers. The eyelids wiping away the gunk and grit that would otherwise obscure our view. That, scientists knew. It's why we don't notice ourselves blinking that was the puzzle.
It's actually quite a big interruption to our visual input, because every time you blink, you're basically turning the lights off for about 140 milliseconds, which, if you actually did turn the lights off, would be really, really obvious and you would notice it. And yet somehow this happens every 5 seconds and we don't notice it. And so we're wondering, why, how is it that we don't notice our blinks and what's going on in the brain?
Davina and her team set out to discover why humans aren't disturbed by these mini blackouts. This is Ian, our volunteer blinker. He's an average guy. Like most of us, he blinks 10 to 15 times a minute. And each blink lasts between 100 to 150 milliseconds. To find out what goes on in his head, other than girls and football, Davina put him in an MRI scanner.
There we go. So just shuffle up a little bit.
Once lying down on a pricey bit of brain probing kit, Davina had to devise a way of seeing if Ian's brain reacted differently if he blinked with the lights on. And that's what this light on a stick is all about. The idea is to stuff it in Ian's mouth, so it lights up his eyes from the back. That means when he blinks, the light levels in the eyes will remain the same. Now all we have to do is see what goes on inside his brain. And the results were astonishing.
What we found was that parts of our visual system appear to be sort of shut down or suppressed while we're blinking.
The bits of Ian's grey stuff that turn off are all to do with the visual system. The effect of them turning off means not that things go black, but we're simply not aware that there's been any change from the moment the eyes begin to close to the moment they open again. The eyes close for nearly 1 day a month, 9 days a year. That's around 2 years in a lifetime spent in this semi-conscious state. You might feel a bit annoyed that you're missing so much, but put your mind at ease. You see, this is what you'd see if your brain did not switch off as you blinked. And when you consider we blink 20,000 times a day, it would probably drive us mad.
So, you know, you might ask, what's the point of this? Why do we not want to notice our blinks? Well, if you imagine turning the lights off every 5 seconds for your entire life, that would be incredibly disruptive to your, you know, just everything.
So it seems the old saying is true. Blink, and you really do miss it. Still to come on Experimental, flying rats, erupting water, smashing bananas, and why women love chocolate.
Don't try this at home.
But first, question. Can anyone be bothered to go out and get some milk from the shop in the rain? Nah. But if you were one of our test department demonstrators, the question would have been slightly different. Who will get wetter? The one who runs to the shop or the one who walks? Will the slower one get more on the head but less on the chest, while the fast one will be in the rain less but get a wet tummy? To solve this universal dilemma, we built this device, called the Precipitation Monitor 3000, also known as some sprinklers and a few bits of wood. So here's the experiment. First up, walking through the rain. And here's the result. Using their Moisture Analyzer 3000 machine, the test department found that Horace absorbed 250 millilitres of rain. Now let's see what happens to Horace when he runs through our machine. Go on, fast as you can, lad. After 10 minutes in the moisture analyzer, we find that when running, Horace absorbed only 180 millilitres. Scientific proof, if you need it, that running through the rain keeps you drier. Now, what about that milk? In a moment, we'll be flying high with rat bits and having fun with microwaves. But first, let's cool off.
Hello.
Welcome to the ice cream capital of the world. No, not Italy, Bristol, in the west of England. Because when it comes to making ice cream, physicist Peter Barham from Bristol University has it licked. He scooped the world record for making a litre of ice cream in the shortest possible time. And it's all thanks to one very special ingredient, liquid nitrogen.
Done.
18.78 seconds. How cool is that? According to the scientists, ice cream is a mixture of 3 states of matter: solids, liquids, and gas.
The solid is the ice crystals and the fat particles, which also crystalline. Liquid is some of the sugar, which is dissolved in water. A very, very thick mixture, a bit like golden syrup, only much, much, much thicker. And of course, the air, which is the air bubbles, and that makes the gas. So 3 phases all mixed together, and the way in which they mix together makes good ice cream or bad ice cream. So the key ingredients of ice cream are cream, funnily enough, which has got fat particles suspended in water with a bit of sugar dissolved in the water as well. And then a bit more sugar because we need extra sugar to make it work properly. And that's basically all ice cream mixture is, although you can add flavouring and you can add nuts and chocolate and things, but they don't really have any effect on the physics of ice cream.
The key to making good ice cream is to keep the ice crystals small so you don't notice them in your mouth. And that's where the liquid nitrogen at an amazing minus 196 degrees Celsius, comes in.
What it will do is make my ice form very quickly, very, very, very small crystals. So you can see it's gone really cold now, and I've got my ice cream. My ice cream actually has gone so cold that it's actually too cold to eat now, but it'll warm up again to make good ice cream in a minute.
But liquid nitrogen's not just good for making ice cream. If you're mad enough to play with something that can freeze you in seconds, you can have all sorts of fun.
Liquid nitrogen is really, really cold, 196 degrees below 0 Celsius. I'll show you. If you put a banana in there, that boils the nitrogen away. Put some wood over here, and I'll get a nail a moment, and I can take my banana out now it's cooled down, and we now have actually a split banana, a banana split, very quick way of making one. And I can take my nail and I can try and hammer it with a banana. And two things will happen, either it will go in or I will end up with breaking the banana in pieces. But and the banana eventually falls apart as a hammer. But that's how cold liquid nitrogen is. You can make a banana into a hammer.
Enough of the DIY. What does this liquid nitrogen ice cream actually taste like? Will it bring Dr. Barham Knickerbocker glory, or just an icy stare?
Liquid nitrogen ice cream, sir?
Yes, it's official. Dr. Barham's nitrogen-powered ice cream is not only the fastest in the world, but 5 out of 5 of his own physics students agree it also tastes pretty cool. If ice cream's not your thing, then how about chocolate? Here's a question. Why does this and this have the same effect on one of these? The answer is that both men and chocolate give her that loving feeling. Let's forget about the man. What is it about a piece of chocolate that's such a turn-on for the ladies? The answer lies deep within its metabolic structure, an interesting chemical called phenylethylamine. You may not have heard of it, but it's very important in making you feel good, in that loving kind of way. That's why nibbling on a lump of chocolate can trick you into thinking you're nibbling on something else. Before we finish on experimental, we'll be looking into the future of aviation. 25,000 rat brain cells in a pink dish. But first, let's do dangerous things at the test department. There's nothing a test department tester likes more than a heap of sugar in a cup of tea. The perfect way to kick off a day at the lab. But welcome to Hell's Kitchen. Imagine if you woke up to a cup of tea that did this. So what was that all about? Well, you've probably been told that water boils and turns to steam at 100 degrees Celsius. And in your kettle, that's pretty much what happens. Boiling occurs when a liquid, water, turns into a gas, steam. But in order for this change to happen, the water not only has to reach 100 degrees centigrade, but it also has to have some tiny impurities within it, such as a grain of dirt, around which the steam can form. So if your kettle is super clean and your water is super pure, then there is nothing around which the steam bubbles can form. You can then create superheated water, water that's liquid at over 100 degrees centigrade. The key is to use a microwave. It heats quickly without disturbing the liquid.
Do not try this at home. It's completely irresponsible and very dangerous.
Taking the professor seriously and donning the correct safety equipment, our test department tester can now take out our superheated water. Looks pretty normal, doesn't it? But add some sugar, effectively an impurity around which the steam can form, and the results are pretty explosive. Now that's what I call a quick cuppa. If you've got an X and Y chromosome, with the resultant hairy chest, it's a pretty good bet that you've fancied yourself at the controls of one of these things. And it's a pretty safe bet that the closest you'll ever get is a computer and a CD-ROM. However, that's a lot closer than most rats get, unless they live here at the University of Florida. You see, it's this little chap and his mates, or rather cells from their brain, that are in charge of flying this simulator. It's all the work of Dr. DeMaas, a neuroscientist who's interested not only in how the neurons in brains work, but in finding out ways of making them work for us.
The basic goal of this experiment was to study ways that you could interface a neural culture, a living neural culture, to a device, an airplane, and have it learn to fly.
What Dr. DeMaas has done is got the neurons in this dish to think. That's right, no one has told them how to fly a plane. They've worked it out by themselves. So how do you make a rat-brained pilot?
We take a little bit of tissue from the rat's cortex. So if you think of a brain, you have the wrinkly portion of your brain. We take a little bit of that tissue and we digest it with an enzyme to essentially give us the individual neurons separated into a liquid.
This brain soup, literally 25,000 individual unconnected neurons, is placed on top of a matrix of 60 electrodes. Dr. DeMaas now has the beginnings of a brain that's ready to teach itself to fly. All he has to do is plug the matrix into his computer and set the program off. Almost immediately, the individual neurons begin to form a complex network, the beginnings of a thinking brain. What's happening is that the cells are receiving signals from the computer and sending their own signals back to the computer. If they send the wrong signals, then this happens. But with time, the neurons manage to form a network that will react correctly to the incoming signals and so keep the plane in the air.
Ooh, I can fly!
In fact, this mini brain can get so good that it can negotiate mountain ranges and thunderstorms like the best Top Guns around.
I think the most enjoyable part about that particular experiment was the fact that you could take a collection of neurons who didn't know how to do anything and then provide inputs so that over time it could learn to do something. Right? So in the end, you can take one of these networks, plug it into the system, right, and it can fly. It can fly the plane.
You'll be pleased to know that Dr. DeMaas isn't proposing that the next generation of Boeings are piloted by a dish of rat brain. But what this pink rat cyborg is doing is to help lift the lid on the way the brain learns at a cellular level. So perhaps in the future, when a real pilot does this and gets a dunk on the head, we may have a better idea of how to fix him up and get him flying again.